Okay, let's look at this problem. And we need to use work energy equation to solve this problem. However, we have two masses in this problem. Let's first look at kinetic energy at position 1, position 2. So the system is released from rest. So the kinetic energy T is 0 at position 1. At position 2, we know both block B and the disk will move. So the kinetic energy from the disk can be analyzed in terms of the mass center G, which is going to be 1/2 mvg squared plus 1/2 ig omega squared. And the second part of kinetic energy at position 2 will come from the block B, and it can be expressed as 1/2 mb vb squared. So this is from block B. Now let's look at work done from different forces. The first force we have here is this weight force at block B. And potential energy at position 1 is 0 if you set the position 1 has the 0 potential energy as a reference. And since the block B will move down, and therefore the new potential energy at position 2 is negative mb gd. D is the distance it traveled. And the weight force at the disk is acting on negative j direction, but the whole disk is traveling to the positive I direction. So this force is acting at a perpendicular to the motion, therefore it does no work. So both potential energy from that weight force are zeros. Now let's look at the spring force Fs. At position 1, spring is unstretched, so there's no potential energy. At position 2, spring is stretched with a distance d, so d is the change of length on the spring. Therefore, the potential energy at position 2 equals 1/2 kd squared. Now you have all the components, T1, T2, V1, V2. Plug them into the work energy equation. And once you plug everything in, you will see you have Vg, omega, Vb. They're kind of like 3 unknowns, but you only have 1 equation. And how do we build 2 more equations? And you will need to use equations from chapter 2. And the first equation you're going to have is inside of a rigid body, the disk, Vg, which is the velocity at point G, would have a relationship with the contact point, the no-slip point C, and Vg equals Vc plus omega cross product Rg/C. Another equation you can build is for Vb. If you go back to the problem, Vb is how fast this block B is moving, right? And B is connected with this rope on the disk. Therefore, at that point, it should have the same velocity as Vb. So we can translate that to the disk. So at point B, the velocity at that point should be Vb as well. And Vb should have a relationship with Vc, which is the no-slip contact point. And Vb equals Vc plus omega cos Rb/C. So now you should have 3 equations and 3 unknowns. What you can do is, from those 2 equations, you are able to write Vg and Vb in terms of radius and omega. Once you substitute Vb and Vg with omega, and you only have omega as the only variable, only unknown in this equation. Alright, good luck in solving this problem.